of f dash x, basically, or derivative, right? Now, very simple concept. If you have a function which is, let's say, f of x equals to x squared, if you find the derivative of this function, what would that be? 2x, correct? This was a quadratic, so quadratic is downgraded, 2 power has been downgraded to 1. So a derivative always takes 1 power off from your polynomial. So it reduces the power of polynomial by 1, correct? So a quadratic became a linear. Similarly, if it would have been a cubic, like f of x equals to x cube, f dash x will be 3x squared. And if I find the double derivative, it becomes a linear. And if I find another derivative, it will become a constant, which is 0. So it keeps on reducing the degree of your polynomial by 1. So if I plot a graph of original function f of x equals to x squared, it will be a parabola. So obviously the graph of the f dash x should be a linear. Correct? Should be something like this. Right? A line. But now let's understand, if I don't have this and I've got just this graph, how do I draw the graph of the derivative straight away? Right? Very, very simple and basic rule. Right? No dramas here. Shall I take this off?
Yeah.
Give me a shout if you don't understand, okay? Let's say you've got a parabola. Let's say f of x equals to ax squared, right? And let's say this is not ax squared. Let's say f of x equals to ax squared. And this intercept at x is x1, right? Now, if I have to draw the graph of f dash x, what I will do is I will create an exactly same quadrant underneath it, 4 quadrants underneath it. And wherever my turning points are, for example, here, even if this is not the x-intercept, let's say it is turning somewhere, right? It's turning somewhere. That's the point, right? I could have taken that example, but I don't want to confuse with the x-intercept because I have to create an x-intercept here. So for any turning point in my original graph, I will just mark it as an intercept on my derivative graph. So this is, I'm trying to draw f dash x now. So if this point was x1, y1, so this point obviously is x1. So I will take that point exactly underneath it into my derivative graph, and here I will make an x-intercept, not the turning point. I'll mark this point as an x-intercept. Right? Point 1 clear? Then I'll have to analyze the graph very closely and see how the graph is turning. From this point to this turning point, the slope of the graph is negative, right? And at the turning point, the slope of the graph becomes 0. What was derivative? As explained in my last session, what is derivative? Derivative is the slope, gradient, rise over run of the tangent to a point on the curve. So that means if I keep drawing tangents here until this point, the tangents have negative slope, right, Aishka? And at this point, the tangent has zero slope. That means tangent derivative is zero. Now, this graph here is the graph between f dash x and x. So, the x at this point at x1 in the original graph, the slope of the tangent is zero. That means the derivative is zero. What is derivative here? The y-axis. And when your y-axis is zero, what does that mean? The x-intercept. So that means this point, and that is why I've marked this point on the x-axis, because my derivative is zero at this point. Did we get it? I'm not just blindly telling you put an x-intercept, I'm telling you why. Okay, now slope has been negative. That means f dash x throughout from the negative infinity, from the infinity of the y till this point is negative. That means f dash x is negative. That means it must be something like this. It is traveling from infinity to zero in the negative direction. You see f dash x, this is negative f dash x. So it is basically increasing from, because it's negative infinity, from the negative infinity, it has approached to zero. Does that make sense? Yes?
Yeah.
At this point, it is zero. It has hit the x-axis. What has happened here? The f dash x starts to become positive. The slope starts to become positive. That means from this point, and it will go until positive infinity. This will be negative. Sorry. So that's it. That's the graph. Does that make sense?
Yeah.
Parabola has become a linear. Let's try to do one more. I'm taking this off the board now. Let's do a cubic and try. Let's do a cubic. So let's say it's gone here. Let's say we've got something like this, right? Okay? Let's say there are two turning points here. The turning points are, let's say, A comma B and C comma D. A comma B, C comma D. What's the value here? A. Could be negative, could be positive. Right? What's the value here? C. Correct? So far so good. This is f of x. Now I'm plotting f dash x. So this is f of x and this is x. This is f dash x and this is x. Now let's look at the x component of the turning point, A and C. So what you do is A, C. You mark two x-intercepts, A and C. And now let's look at this graph in parts. First part is from negative infinity to this point. right? Or from the graph is, so yeah, the graph is increasing, positive slope, positive slope. So when you have positive slope, that means your f of x is positive. Positive slope means f of x is positive. Slope means f of x, f dash x. So f dash x, right? Your derivative is positive. So positive slope will hit 0 at a. Positive slope, the slope will remain positive until a. So can I say in my derivative graph, I will have something like this. Something like this. This is the positive f dash x. It's all positive and it becomes 0. Slope is positive and becoming 0. Next part. From A to C, slope becomes negative and 0. From A to C, slope becomes negative and 0. Right? And then from C, it becomes positive again, the f dash x. It goes up. Another way of looking at it is, when your slope is positive, always make sure that your f dash x stays above x-axis in the derivative graph. Positive, irrespective of whether it's sitting here or here, wherever. Slope positive means it sits above the x-axis because f dash x is positive. So, and then from 0, from A to C, it's negative. And then you could have asked me a question, why I have drawn a curve like this? You could have asked me a question, why? You didn't ask me.
It's one less than a cube, which is a quadratic.
Fair point, but forget about that for a second, right? Why on earth I have drawn a line like this, a curve like this? Why did not I just said something like this, right? Because from A to C, the slope is negative. If I would have drawn a line like this, obviously the slope is negative, but then I have to, slope starts to, from 0, slope starts to enter into a negative zone. It remains negative, 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 negative. At C it becomes 0, and all of a sudden after C it becomes positive, 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 positive. So if I would have drawn a line like this, and let's say I've hit C here, I cannot bump it like this, because even if I bump it, it still sits underneath the x-axis, no? That is why I have to curve, so that at C I can cross the boundary and become and make my f dash x positive. Does that make sense? Does that make sense? Understand? Oh, good. Cool. It's very straightforward and simple. Okay, let's try to do one question now. Let's try one more, maybe one more.
Okay.
Let's do one more. I mean, hypothetically, let's draw one graph, right? So let's say I'm just drawing something. Let's say I have, again, let's take the example of cubic, right? Let's say you've got something like this. You've got y equals to x cube is like this graph, right? Your cubic, y equals to x cube is this kind of a graph. And this point is called what? the point of inflection, not the turning point. And this is x, and this is f of x. So what I do is I draw a graph exactly here, and since this is my 0, this is my point of inflection is here my derivative is 0, so I mark this point here as my intercept, right? Whatever this point is. I just translate this point. Now, let's analyze it. Now I'm drawing it with my red pen. That's the derivative graph. Slope is what? Positive, 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 0. Slope is positive, 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 0. So that means it becomes something like this, because this is my dear boys and girls, this is f dash x. If it is positive, it will come from the top, hit 0. Right? At 0, it doesn't change its behavior. Positive, 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 positive. It will not slide down now, because the moment it slides down, f dash x becomes negative. This is negative f dash x. It will bump back up. So y equals to x square, x cube is now 3x squared. Derivative. Aishka, does that make sense?
Yeah.
Right? Absolutely, crystal clear. There are very few rules that you need to take care of. Right? Okay. Can you tell me, shall I take this off the board, please?
Yeah.
Yeah?
No.
Aishka, yes?
Yeah.
This was taught in grade 11. But anyway, let's make another graph. Let's say we've got something like this. F of x and x. This is 1. All good? Now, can you draw the derivative graph for this one? This is a linear one. Now, let's quickly draw that and check the understanding. I don't care about the y here, right? Or should I? Yeah, okay, I'll flip the conversation. Okay. Yes, tell me, how would the graph look like? Where do I draw that horizontal line? Horizontal or vertical?
Horizontal at y equals 1.
Y equals to 1. Yeah, right?
Yeah.
And explain me why.
If you took the derivative of x plus 1, you just get 1 as the end result.
Sorry?
The derivative of x is just 1. If you did x to the power of 0 equals 1, so it'd just be a horizontal line.
A constant,
Yeah, constant.
right? Anything else? Anything else that you can think of? Anushka, did you get this?
Yeah, I did.
Exactly the same, Amel? You? The slope is positive. Slope is positive. what is, so that means it will always stay above x-axis, number one. So that's why it's staying above x-axis. This is f dash x. Right? Now number two, what is the slope here? That's where this line is going to cut. F dash x, right, is the slope or the derivative. What is the slope of this line? If you draw a tangent at any point, that will be the same tangent because it's linear. What is the slope of this line? This is 1, this is 1. Right? So slope is
1.
rise over run. Slope is 1. That is why you draw here. Does that make absolute sense and it's gone straight inside your head with not even 0.1% of confusion? Right? Good. Now, and shall we quickly find the slope by any chance? So this point is -1, 0, and this point is 0, 1. Yes? What is slope? y2 minus y1 over x2 minus x1. Yes? y1, y2, y2 minus y1 over x2. x2 is x2 minus x1. So -1 over 1 is 1. That is why it's 1, it's the line here, not here. All good? Can you draw the slope of something like this here now? If I say you've got, and I say this is 2 and this is 2. Can you draw the derivative of this term? Quickly. Aishka, I need an answer from you. And Romel, you will validate it. All good? So, -1. Right? A negative line, a negative slope, 2 and 2 makes the slope as 1. Finish. All good? Any challenges?
No.
All right. Cool. Okay. Let's now quickly do the chain rule. Just out of curiosity, one thing that I wanted to sort of, I'm just